Okay, so again, update on the exams. I'll start grading those this afternoon. Hopefully I can finish them today later and have the scores posted. For sure I'll have them graded and passed back tomorrow. Anybody have any questions yet on homework? Homework is posted for section 5.1. It's due Thursday, both the written and online. Is there anybody that wasn't here yesterday that might want a copy of the handout? All right. So at the end of class yesterday, I had people start working on the last problem, solving right triangles. So we'll wrap that up. I'll go through that, and then I have a worksheet that I'll pass out that everybody can get some practice on. So example 6. I'll remind everybody. Actually, first let's do a little bit of a reminder. So if you have a right triangle labeled adjacent, opposite, angle theta in the bottom left corner. My triangle's a little slanted here, but that's okay. The side opposite the right angle is the hypotenuse. And I think we defined sine of theta to equal opposite over hypotenuse. Cosine of theta to be the length of the adjacent side over the hypotenuse. And tangent of theta was the ratio of the opposite side and the adjacent side. So there's sine, cosine, and tangent. And then, so that would at least give you the values of sine theta, cosine theta, tangent theta. You could know adjacent, opposite, and hypotenuse and not know the angle and still calculate these values. And then if you wanted to recover the angle, you can just convert all of these expressions to be in terms of arcsine, arccosine, and arctangent. So remember, from going from an original function to its inverse, the input theta becomes the output, and the op over hypotenuse becomes the input of arcsine. So if you know all the lengths of all the sides, you can recover the angle. You can also use arccosine of adjacent over hypotenuse, or you can use arctan of opposite over adjacent. Okay. And then if I label this other angle, say beta, the other fact is all three angles in a right triangle have to add to 180. If you take away the 90-degree angle, theta and beta have to add up to 90 degrees. But in general, all three sides have to add, or all three angles have to add up to 180. So we're supposed to solve each of these following triangles. So in A, it said the angle theta was 26 degrees and the hypotenuse was positive 8. So I'll start by drawing a picture. Should probably draw an angle that's not so large. Okay, so here's my right triangle. In the bottom left, I have my 26-degree angle, and then the only other information we're given is that the hypotenuse is 8. We want to find all the other missing sides and all these other two missing sides and this missing angle. So that's beta. We'll say that's the adjacent side of the angle, 26 degrees, and this would be the opposite side. So we need to find adjacent, opposite, and beta. Okay. I think maybe the angle might be easiest to do first. So this angle beta, since the 26-degree angle and beta have to add to 90, that means beta should just be 90 degrees minus 26 degrees. Okay, so is that I think what everybody should have ended up getting here? And this ends up being 64 degrees. So the given angle is 26 degrees, the missing angle has to be 64. And then, anybody want to share how they found either adjacent or the opposite side? You're going to use your trig function, sine, cosine, or tangent. guess I could just do it.
I did sine of 26.
What'd you do?
I did sine of 26.
You did sine of 26, Ocean? Okay, so if you apply sine to this 26-degree angle, that'll give you an expression involving the opposite side and the hypotenuse. So this would equal op over 8. Okay. So you have to pick a trig function that, when applied to that angle, involves one of the sides you're trying to find. And then from this, we would just solve for the opposite side. That would be 8 sine of 26 degrees. And what did you get, say, rounded to 2 decimal places? What was it? 3.51, was it? Okay. I think I did it this morning. I made a video recording, so I think I also got 3.51. And then, what can I apply? Now there's a couple different ways to get the adjacent side. Since you know the opposite side, you could use Pythagorean theorem to solve for the adjacent side. But to get the length of the adjacent side exactly, or a better approximate, I can, instead of applying sine to that angle, I can apply what trig function this time?
Cosine.
Okay, so if you apply cosine to the 26-degree angle, that's because I know the hypotenuse, but I don't know this adjacent side, and cosine is what relates the adjacent to this hypotenuse. So cosine 26 is going to be the length of the adjacent side over 8. And then if you multiply both sides by 8, the length of the adjacent side is 8 cosine of 26 degrees. And it should be 7 point something.
0.19 is what
7.19. Okay. So the other angle is 64 degrees. The opposite side is 3.51 approximately, and the adjacent side is approximately 7.19. So everyone okay there? All right. So part B then, what they give us there, instead of giving us an angle, they just give us 2 of the sides. Is it okay if I erase part of this? Let me just wait a minute. Maybe I'll do it over here. No, I don't want to erase my summary information. That's okay, I'll just do it right here. Okay, so part B says that the adjacent side of the angle is supposed to be 14. The opposite side is going to be positive 2. So you can draw a right triangle. In the bottom left corner, just label that the angle theta. And then with this being the angle theta, the adjacent side, the side touching the angle, is going to be 14. And the side opposite the angle is going to be 2. Let's call that the hypotenuse, and again we'll call the angle in the upper right corner beta. Okay. Everybody okay with my labeling scheme there? Okay. Okay, so suggestions. We can do this in a couple different orders. I could find theta first, then find beta, and then find the hypotenuse. I could find the hypotenuse first, and then find the 2 angles. Anybody have any suggestions?
I found the hypotenuse first.
Okay, so you found the hypotenuse first, so remember, in general, if you add the sum, or if you sum up the squares of the opposite side and adjacent side, that'll give you the hypotenuse squared. So the hypotenuse is just going to be the square root of op squared plus adjacent squared, which for us is the square root of 14 squared plus 2 squared. That's 14 squared. Is this going to end up being a whole number?
Square root 2.
Does work out. So you get 200 underneath the radical, or the whole thing?
Underneath the radical.
Okay. Let me just double check. Okay, so you get root 200, which will be, I believe,
10 square root 2.
10 root 2.
Yeah.
Because that's 2 times 100, and the square root of 100 is 10. And the 2 stays underneath the radical. Okay. So now we know the hypotenuse. That's going to be 10 root 2. And then how about finding the angles? Now we can use any one of these three formulas here.
Tangent's easy.
So yeah, we'll just go ahead and do tangent. I like to actually write this first. I just apply tangent to the angle theta, and that's going to equal the ratio of the opposite side to the adjacent side. Okay. The reason I like to write this first, it kind of helps me see where this comes from. Once I have an expression, tangent of theta equals 2/14, when you convert it, the input theta becomes the output, and the right-hand side is just going to become arctan of the output 2/14. So that's that idea again of when you go from a function to its inverse, the inputs and outputs swap. And then make sure your calculator, technically you could have it in radian modes, but we'll work with degrees. Anybody plug this in?
I got 8.13 for the bottom.
8.13?
And then the other one, I just switched the two to get the other angle in the arctan.
Did you do?
14/2.
Okay.
And then I got 81.87 for the other
14/2. Ah, yeah, I guess you could do that too, couldn't you?
Yeah.
Because you could apply tangent to this angle. Tangent of the angle beta would be the opposite side over the adjacent side. I believe that just ends up being 7. Let me be careful about it.
No, well, yeah. But yeah, and then you'll get 81.87.
Okay, so when I do beta equals arctan of 7, you get, what did you say?
81.87, which works out because those equal 90.
Yep. So, two ways you could have done this. Okay. One is I could have just done 90 minus 8.13 degrees, or you can just apply tangent to that other angle, convert to arctan, plug it in your calculator, you get 81.87, and like Kirsten said, if you add that to the other angle, you will get 90 degrees. And does this kind of make sense? If the adjacent side is long and the opposite side is short, that means that your angle should be pretty small. And 8.13 is a pretty small angle. So that's a sensible answer. Which is why beta is such a large angle, because the opposite side is longer than the adjacent side. Alright, any questions? Alright, so for the next, let's see, it's 9:43, so let's maybe say like 20 minutes or so. Go ahead and work on this. You can work in groups or individually. This is not to be turned in, it's just for practice and your own reference. And then we'll go through this together at the end of class in the last 15-20 minutes.